first part of these notes, and then we'll go into the lab, okay? So, is everyone ready? Okay, so this chapter is, honestly, we're kind of talking about the agricultural side of chemical use, so pesticides, fertilizers, so on and so forth. And so I feel like a lot of this unit is repeat of the units we've kind of already talked about. It's just we're applying it to different things. So we already talked about the nitrogen cycle. We've already talked about the water cycle. We've already talked about pollutants. We've already talked about these things. Now we're just kind of putting them in context to real-world examples. So this one's talking about agriculture. So first of all, plants need lots of things to thrive. We need macronutrients. Macronutrients are the ones they need a lot of. And this would be things like carbon, hydrogen, oxygen, nitrogen, phosphorus, potassium. And they need lots and lots and lots of these. Okay, where do they get a lot of these from? They get a lot of these from the sun, and then they make their own food. Okay, but what they don't get, they have to get from where? What they don't get from the sun and what they don't make, they get from where? Soil. The soil. Okay, so another thing that plays a big part in plants is the pH. Okay, the pH of the soil will determine a lot of times how well the plants will grow, how big they will grow, how strong they will be, how healthy their products will be, how nice looking they will be, so on and so forth. So around here we have clay soil, right? We have soil high in clay, and these are usually very acidic, and therefore the nutrients will dissolve and wash away relatively quickly, which is why we have an erosion issues around here. Limestone soils, again, we have some of that around here as well. Depends on where you are. If you go down towards Branson, we have a little bit more clay. Up here we have more like limestone. But limestone soils are basic, and therefore the nutrients precipitate out and are not available. Because what happens in limestone and water? We talked about this a few chapters ago. Limestone will dissolve. And so the nutrients will dissolve away from the limestone, so therefore it'll be washed away into the water in the lake systems, and they won't stay in the soil. So basically there are some ways that you can fix this. If the soil is too basic, you can add alum, okay, and it'll give you the reaction you see below. Basically, it is reacting some of the hydroxide it's taking. Hydroxide is what makes things. Hydroxide is what you classify things as basic. So if we're trying to make it something acidic, basic, let's add some base to it and see if we can meet somewhere in the middle. Okay? If our soil is too acidic, you can do the opposite. Hydrogen represents something acidic, so basically we're trying to get rid of some of that hydrogen. So we're probably going to do the opposite. We're going to try to neutralize it with some hydroxide. So we're trying to meet in the middle because we don't want things to be acidic or basic. We want them to be smack dab in the middle. Okay, well, we all know that plants do photosynthesis. So just to give you kind of a refresher on what photosynthesis is, basically, plants need carbon dioxide and water. Okay, well, and of course sunlight. The sunlight kind of is the catalyst to the reaction. But they take carbon dioxide and water, and they will form a sugar. There's lots of different types of sugar. Sometimes it's glucose, sometimes it's sucrose. It depends on the plant, it depends, but it will form some sort of sugar, plus oxygen and, again, water. Okay?
Yeah, for 17.
Awesome.
Yeah, you skipped from this to pH all the way over here.
Should have been just hard.
That's retarded.
I mean, I think it's cool.
Okay, so the nitrogen cycle, you guys remember I'm recording this, right?
Oh, I didn't say anything bad.
Okay, so the nitrogen cycle, remember when we talked about this a few chapters ago, we talked about the nitrogen cycle, how usually it has to be fixed because plants can't use it just as nitrogen. Nitrogen makes up 70% of our atmosphere, but it's not in a usable form. So we have to fix it somehow for the plants to use it. And so does anybody remember how we fix it? What are the processes that fix it? There are two main things that fix it. Fix nitrogen into a usable form. One of the forms is lightning. Lightning will take the nitrogen in the atmosphere and convert it into a usable form. But we can't always wait for lightning, can we? That's not very predictable. And so there's actually bacteria in the soils that will convert the nitrogen into a usable form for the plants to use as well. Okay, but every plant needs a different type of nitrogen. Every plant needs a different type of nitrogen. So this is why a lot of farmers will rotate their crops. If you plant the same crop in the same field year after year after year, it'll deplete the soil of all the nutrients. Some plants will actually put nutrients back into the soil. So if you usually, I think you're supposed to rotate it every 4 years. So like crop you have in the first year, you don't need to have it there again until the 5th year. And so you're supposed to use a 4-year rotation. Fertilizers is the key. Okay, we can't depend on lightning because rainstorms are unpredictable. We can't depend on lightning. We can't necessarily always depend on bacteria because that is a whole nother series of issues. Plus, it's a long process to get bacteria to grow in the way you want it to. And so sometimes we add fertilizers to jumpstart the process. So fertilizers have 3 main nutrients. They usually contain nitrogen, phosphorus, and potassium, which are some of the macronutrients that plants need. Remember, the macronutrients are the nutrients that plants need a lot of. I don't know where it's at in this book.
Page 309 says something about fertilizer.
Thanks.
Okay, so if we look over here at this picture, we see the 3 main macronutrients at the top. But as it goes down, do you guys see how it starts getting, it's like a food pyramid. As it goes down, we need less and less and less and less of these. Plants need all of these in order to thrive, but if we don't have these top 3, it doesn't matter how much we get of the bottom half. Okay, so when we're talking about our macronutrients, sometimes we use manure as a fertilizer. You guys have all heard of this practice before, right?
Oh, yes.
Using like cow manure or smells really bad, but it's high in nitrogen, so it solves the problem.
So how does, like when the Pilgrims came to the U.S., they used fish? How is that?
Probably the fish had a bacteria in them that would then fix the nitrogen. So it probably actually wasn't the fish, but it was probably a bacteria that was found in the fish that would do the same process. So it probably wasn't actually the fish. Another way so manure will make up is about 2% nitrogen, so it's one way that the plants can absorb the nitrogen. Another thing that we can do is we can use ammonia. Ammonia, everyone knows what ammonia is, right? We use it as a cleaner. Well, sometimes we can use it to fix our nitrogen as well. And then sometimes we also can use natural gas in fertilizer production. So all of these contain nitrogen. So then we just have to make it in a usable form, some way, shape, or form. Okay, so like we just talked about ammonia. Ammonia is about 85% nitrogen. Well, why don't we use that? That sounds pretty great. Well, ammonia is a big part of ammonium nitrate. Ammonia and ammonia is different by 1 hydrogen. So it doesn't take much to go from ammonia to ammonium. And ammonium nitrate is very explosive and is what was used in the Oklahoma City bombing. So we don't really want a whole lot of that floating around, which is why if you guys have ever tried to buy fertilizers, just like when you're trying to buy cold medication, sometimes there's a limit to how much you can buy. Another source of nitrogen is something called urea. This is 45% nitrogen. Another one is ammonium sulfate. Ammonium sulfate is different from ammonium nitrate, but it still has some of the negative qualities as ammonium. Remember, ammonium nitrate was the one that was explosive. So it's not quite as reactive, but it probably still has some of those reactive tendencies. One of the big problems with using fertilizers, and again, we talked about this in the last few units, is we overuse them. Okay, when you don't, it's not really a perfect science. You can't measure how much fertilizer the plant needs. You just go dump some on the plant and hope it's enough, right? If the plant doesn't seem to be doing any better, you just go put some more on the plant. That's how it's practiced. Well, the plant only absorbs about half of the fertilizer you give it, and the rest of it is part of the runoff when it rains or whatever. So it gets ran down into your sewers or into the rivers and lakes, and then eventually it finds its way into a lake. And do you guys remember when we talked about fertilizers that if we get too many nitrates in the water system, it causes an increase in algae. An increase in algae kills off everything else, right? Because it blocks the sunlight. Does anyone remember what that's called? Eutrophication. Kind of remember that test question last unit? Okay, so if you look at this picture of the Gulf of Mexico, because if you think about how much stuff gets dumped into the Gulf of Mexico, because the Mississippi River lets out right there, correct? So the Mississippi River is carrying water from half of the United States, probably. A good half of the United States runs into the Mississippi River. Well, when water is moving really fast, it's carrying the nitrate with it. But what happens as soon as it dumps into the Gulf of Mexico? What happens to the speed of the water? It slows down almost instantly, so it drops all of the nitrates because it can't hold on to it anymore because it's not moving so fast. And so this down here in this picture is the dead area of the Gulf of Mexico. Pretty much nothing grows there. Why? Because it's so high in nitrates, so high in algae that nothing else can grow. And so it's kind of starting to become a problem. Okay, well, nitrogen isn't the only thing plants need. What else did plants need? They needed nitrogen, they needed phosphorus, they needed potassium. Those are the three big ones, right? Those are the macronutrients. Okay, well, we're not just worried about nitrates, we're also worried about phosphates. We can get phosphates from bone meal and phosphate rock, which are all things that we can find in our crust of our earth. Okay, so we can kind of just mine for them. Potassium sources are wood ashes or potassium salts. A lot of times when you're buying a fertilizer, you're not buying a fertilizer that is 100% nitrates. You're not buying a fertilizer that is 100% phosphates. You're usually buying a fertilizer that has a little bit of each. And some people prefer different fertilizers. Some people, different plants prefer different fertilizers. So you honestly just have to find the fertilizer that works best for the plant that you are raising, because not one fertilizer is going to work for everything, because every plant needs a little bit of a different ratio of nitrate to phosphate to potassium. So therefore, mixed fertilizers is actually what you will find in the store. You will find it, I want to say usually it's like 10% phosphates, 30% nitrates, and that's just me trying to remember from looking at the bag. But I honestly don't remember off the top of my head. Okay, another thing that we use, we've fertilized our plants. Our plants are growing now. They have everything they need. We also, now that our plants are growing, we also have to start worrying about pesticides. Okay, pesticides are a big problem when it comes to crops and your flowers and just your things outside your house. You want them to stay nice. You want them to stay looking nice. And so we often use pesticides. These are used to control insects. In 1945, the global use of pesticide was 110 million pounds per year. By 1995, we had upped that to 5.5 billion pounds. And then 2007, we dropped it a little bit back down to 5.2. But considering it was 110 and now we're at 5.5 billion, 5.2 billion, I mean, this is a giant jump, correct? Okay, so we're starting to see some of the negative effects. Now that we've been using them for so long, we're starting to see some of those negative effects. We're starting to see the side effects of what happens when you use all these pesticides. The U.S. alone uses 1.1 billion pounds per year, which is about 22% of the world's usage. So we're definitely not a quarter of the world, correct? And we are accounting for 22% of the pesticide use. So where do you think the majority of the pollution is going to be? Around here. So hopefully we're using safe ones, but again, the bad part about chemistry is sometimes we don't know the side effects until we use them. So there are lots of different types of pesticides. We have insecticides that kill insects. We have fungicides that kills fungi. This is types of molds, rots, blights that can grow on your house. We have herbicides, which are used to kill weeds. We have algicides, which are killed algae. You guys have heard of the majority of these before, right? You can buy the majority of these at Walmart, especially this time of year when stuff starts to bloom and you're trying to protect your house. Okay. Herbicides are the most used. 40% of our pesticides are herbicides. So we're trying to kill our weeds in our lawn, make our house look pretty, right? Followed by pesticide, which is 17%, and then fungicides, which is 10%. Okay, corn uses more fertilizer and pesticides than any other crop. Okay, which doesn't sound that crazy, except corn is not only do we use it for food, but we use it in a lot of other industrial type things. We use it to make a lot of stuff. So we have to produce a lot of corn to keep all of our products where they need to be. And so considering it uses more fertilizer and pesticide than any other crop, and we grow so much of it, that alone is a big percentage of our pesticide use. In 1910, the Federal Insecticide Act had the USDA ensure the quality of insecticides. In 1947, the Federal Insecticide, Fungicide, and Act had the USDA regulate all pesticides and said that pesticides must be registered. And this was amended in 1959 and in 1964. Basically, they wanted a paper trail as to who was using what pesticides where. Okay, it's not that they necessarily cared that you were using it. They just wanted a paper trail to figure out if something went wrong, where was it coming from, where was the source from, what's making whatever the environment polluted. In 1972, we had a big push to kind of start to amend this a little bit. The administration moved to the EPA, and we amended it in 1975, and then again in 1978, and then again in 1980. And basically, we were trying to register all of the pesticide use as their general use, where we're just trying to aid in our crop growing and our plants growing, or were people using it when they weren't actually supposed to be using it. So we were trying to differentiate between general use and things that we should probably restrict people from doing. The restricted use applicators must be licensed and take a test at an agriculture extension office. So there are pesticides out there that are very damaging if you use too much of it. They can be very toxic to the environment if you use too much of it. But if you use it in the right amounts, it's perfectly safe. And so basically they made these restricted pesticides, and in order to use them, you have to go take a class and you have to be licensed. Basically, they want people using them correctly, not that they don't want them to use them at all. Okay, so when it comes to insecticides, there are approximately 3 to 5 billion species of insects known, and that's just what we know of. There's lots, there's probably equal that we have yet to be discovered. So the number of insects on the plant is estimated at 1 billion. So there are lots and lots and lots of different species of insects, and then if we just look at one plant, the amount of insects on one plant is probably, we can't even see the majority of them. We would have to see a microscope. So insects play a huge role in how healthy our plants are. In 76% of the total animal mass on the planet is insects. 99.9% of the insects are harmless or helpful, so they pollinate the plants. Or sometimes they will carry seeds so that the plants can grow not just in that area, so that they can travel and start growing in other places as well. However, 0.1% of these are pests, and pests are either agricultural or they can just carry diseases. So the big part about pests, like mosquitoes around here are known to carry diseases. It was a few years ago, it was a big push on West Nile, which it's still kind of an issue, but not as bad as the one as it was, 4 or 5 years ago. The WHO, which is the World Health Organization, estimates our insects consume 1/3 of everything man grows and are responsible for half of the human disease deaths. Just to give you an example, there are 100 to 500 million malaria episodes per year and 1.2 million deaths per year, mostly in Africa, and malaria is carried by mosquitoes. And so basically they bite one person, and when they drink their blood, they also get the disease, and then when they go bite another person, if that blood is still in their mouth, for lack of a better word, when they go to bite another person, some of that blood gets transferred, and malaria is transferred really easily. And so that is why a lot of the deaths is in Africa, because they don't have the things to prevent. Around here, if you're trying to prevent mosquitoes, you can go to the store and we can buy pesticides and insecticides, and you have bug spray. You have all of these things to try to prevent it. So plus, the population, African Americans are more prone to malaria in the first place, and so they're already prone to getting it, and then they have the insect issues. So we also have single crops, and these allow a buildup of large pest populations. So when you have a field or an area with only one type of crop in it, it's kind of like a signal for all the insects that like that crop to go straight there, because there's plenty of food there. They're not going to have to move. They can just stay right in that same location. And so for streets, when it was a habit when it's still a habit when you're building a new what's it called? A subdivision. When you're building a new subdivision, they often plant the same tree in every yard. Well, maybe you're planting an elm tree. Okay, so this is a Dutch elm tree, and basically when they would plant them in the front yard of every house in a subdivision, it would attract a type of beetle, and it would cause the Dutch elm disease. So usually when you have a plant disease on one house on the street, it just goes down the street, because usually it's similar trees, especially around here, because usually, based on the climate, different plants will grow at different rates. And so usually you want to plant something that's going to grow well in the climate, correct? And so a lot of times it'll affect not just one tree, but all of them. And so a lot of times when one tree gets sick in a neighborhood, the neighbors will tell everybody else to have their trees sprayed, because if you can prevent it from the insects from eating the tree or infecting the tree, because sometimes they just, you guys have all seen Japanese beetles, right? They will attack rose bushes, won't they? And they're not killing the rose bush, they just eat all the leaves, and if the bush doesn't have any of the leaves, then it can't do photosynthesis, and so then it can't feed itself, basically. So they're not really doing anything to kill it, so if we put something on the leaves to prevent them from eating the leaves, problem solved. So they will move on and they will go find something else to eat. Okay, however, do you think insects are the only ones that live in the trees? No. So oftentimes when we spray the trees to kill the insects, we also are going to affect birds and some other predatory insects that we don't want to kill. Because some insects are really good, right? We don't want to scare away all of the hummingbirds, because hummingbirds eat wasps and mosquitoes and things like that. So those are kind of nice to have around your house. And so it's just kind of have to be careful at the same time. When we're using insecticides, there's actually two main types. You can use inorganic compounds. So if you remember back last week when we were talking about organic compounds, we're talking about carbon. So inorganic compounds are poisons usually, and they don't contain carbon. So these are stomach poisons. So basically what they're going to do is you're poisoning the insects to death. So usually they are high in arsenic, lead, thallium, mercury. And so you guys all know that mercury poisoning is bad. Well, it has the same effect in insects. So if we can give them a poison, builds up in their system, and it kills them that way, but at the same time it's going to build up in anything that eats it. And so it's not really a great practice to have. These cause the enzymes in the insect to not work properly, and then that's how it kills the insect. So basically it kills them from the inside out. It causes their body systems not to work properly anymore. But if we're using a poison that has mercury in it, if it gets in our food, or you have little kids that are outside playing and little kids put everything in their mouth, that's not really a good practice. And so a lot of times we don't use inorganic compounds. A lot of times we use organic compounds, and we like to use the naturally occurring ones because they're a little bit safer. But a lot of these are kind of like nerve poisons. One that we use a lot is actually nicotine. We've used it since 1690, and it actually mimics one of the stomach poisons that we've talked about up here, except it doesn't happen as fast. Okay, so it has to build up in the system before it starts to infect the insect. So it's not something that happens instantaneously, whereas if you give mercury to an insect, insects are so tiny it's not going to take much of that poison to affect it. Down here we actually have another one. Pyrethrins, which I can't pronounce right, has been used since 1800 and is a product of a certain type of plant, which are grown commercially in Kenya, Ecuador, and Japan. So basically, if you just growing this plant sometimes alone will help prevent the insect that you're trying, because if the insect lands on this plant, it'll give them side effects, so then they'll just move on and they'll move away. So a lot of times if we can plant something around what we're trying to keep insects away from, it'll solve the problem without having to use any chemicals. So a lot of times they try to find some sort of organic fix. If nothing's fixing the problem, then we'll go back up here to our inorganic compounds. But right now they're trying to do the natural thing. All right, so this is where I'm going to stop today. So I told you I'd do about half of it, and then we'll do the other half of it on Tuesday.